Assalamu alaikum. My name is Mujtaba and I am going to be presenting the given topic binary trees. The things we are going to cover in this topic are what are binary trees, what are the different variants of binary trees, and example code for implementation of binary trees. The first thing that we are going to discuss is what are trees. The first thing that comes to mind when we reading the word tree is a trunk with several branches spreading out in accordance with the size of the tree. Now we will discuss what are binary trees. A binary tree is a data structure in which every node has two nodes at maximum, which forms the shape of branches of the tree, with every node with two branches as the name binary suggests. The two nodes are called the left and right child nodes. This is the basic structure of a binary tree. Root is the first node of the binary tree, and the left child and the right child are nodes of root. Now we will discuss the components of a binary tree. A node consists of data and link to its both child nodes. A root is a node root is the first node of the tree. Leaf is a node that don't have any children. A parent, any node apart from the root node, any node with at least one child parent to that child node. Any node with a parent node is called a child node. Any node with a child and a parent is called internal node. The height of a binary tree is the longest path from the roof to any leaf. The depth of the node is the total number of edges from the root node to the target node. These were some of the components of the binary tree. Now we are going to discuss the different variants of a binary tree. Variants of binary trees are different ways of a binary tree can be represented. There are different ways to work with a binary tree and different structures of binary trees. Some of them are going to be discussed, which are a full binary tree. A full binary tree is a category of binary trees in which has either 0 children or 2 children, as it will be discussed in the further slides. A complete binary tree has all the 3 levels completely filled except the lowest level of the tree, as will be discussed. A perfect binary tree is a binary tree if all the nodes have strictly 2 children. A balanced binary tree is the one in which height of the left from the right differs only by 1. A degenerate binary tree, also called a pathological binary tree, has only one child node for every node. The first node is the full binary tree, has either 0 or 2 children and not between, as it can be seen in the given structure. The second one is the complete binary tree. The first 3 levels in complete binary tree are completely filled, while the fourth is not, as it can be seen in the given structure. The third one is the perfect binary tree. As it can be seen, the perfect binary tree has strictly 2 nodes. The next one is the fourth one is the balanced binary tree. The height of the given tree only differs by 1. And the last one is the degenerate binary tree, which has strictly 1 child for each of its node. Now we will discuss the basic insertion program of a binary tree, in which we will insert some values and display them. As in the basic binary tree, there are 2 nodes for every node, so we will create 2 nodes and call them the left and the right node. This condition will display an error message in case of no new node. In this step, we are simply assigning the data to the new node's data. Now we are setting the left and the right nodes to null. In this step, we are making sure that the root is not null, and if it's null, then we will assign it some value. In this step, we will create a node of built-in queue function and call the function of the queue such as push. In this step, we will create while loop and go through all the nodes until the condition is met. In this step, we will create a temporary node and assign it the front of the queue. This step will push the data in the left node, in both cases either empty or full. This step will push the data in the right node in both cases of empty and full. This function will simply print the values residing in the binary tree. In this step, we are calling the functions and passing the values. This step will print the data in the binary tree before insertion. And this step will print the data after the insertion. Now we will try to run the code in dev C++ and see what happens. As you can see in the screen that we have compiled and ran the code, and it is displaying the values of the binary tree before and after the insertion values.